All right, with factoring, with regular factoring like this one, the one thing you want to make sure that you have is a coefficient, a leading coefficient in this case, that's a positive. Now that's a positive one. We don't have to show that, but again, that's the first thing you should look for. If it's not a 1, then you should be maybe looking to factor out from, a number from the 3 terms right there. Since that's not the case, of course, we can move forward. But it's the first thing you should always look for is a greatest common factor that you can factor out. Sometimes what they're going to do as well is they'll say, hey, this one's x to the power of 3, x to the power of 2x, and you can factor out a number or variable from the 3 terms as well. So you have to keep that in mind. Whenever you look at a problem and it says 2-factor, make sure you check to see if you can factor out a greatest common factor. Now, again, I can't do it on this one. It doesn't have any x's in common, and again, that leading coefficient right there is a 1. So I'm not going to worry about that. What I am going to do is, for this one, actually, you know what, I'll probably do this twice, okay? And the reason I'm going to do this twice is because there's 2 different ways to do this. It's the old-fashioned way, and that's to look at this as factoring by grouping. What are we going to do right here? We're going to take the 9x and we're going to split it. What are we going to split it into? Well, we have to look at the 20 right here and find 2 factors of 20 that add up to 9. So we would look through all the factors, such as 1 and 20. Well, if I add those, I get 21. 2 and 10, if I add those, I get 12. Then it's not divisible by 3, but 4 will work. 4 and 5, and yes, if I were to add these, I get a 9. Why do I want these 2 factors? Because it's going to make the factoring by grouping work. Okay, but the 4 plus 5 being 9, that's what I'm going to split these 9x's up to. And we, well, hopefully you guys know this by now, but a lot of math is what we want it to be. In this case, I don't want this math to show 9x. What I'd like it to show as is 4x plus 5x. And again, this is going to allow me to factor this by grouping. The rest of it just kind of stays the same, right? Again, we're going to look at the 20. We're going to look at that with factoring, but having it with the 4x and 5x is going to make it easier to factor. At this point, now we have the groups, right? We have the x squared and the 4x. I can factor out an x from this one, and I'm left with just an x and then also a plus 4. If we've done this correctly, we should end up with, on the right side, from factoring these out, we should also end up with an x plus 4 if we've done this correctly. If not, then I would worry about maybe I've done this incorrectly. But from these 2 terms, I cannot factor out an x, but it looks like 5 and 20, they're both divisible by 5. So I am going to factor out a 5. And what would I have left? Well, 5 divided by 5 is 1. 20 divided by 5 is the 4 right there. So this looks like we've done this correctly. And that's good news, because then I can factor out from these 2 terms the x plus 4s. Okay, so I'm going to factor this out, x plus 4. And then whatever's left over will go inside my other set of parentheses, which is an x, and then also a plus 5. And the last thing you'd want to do with these is just to make sure, again, there's no greatest common factor in the 2 sets of parentheses that you can factor out. Now, if you understand that and you understand how we broke this 9x up by finding 2 factors of the final term here, which they're calling c, and that's fine, then you can use this method all the time. You don't really need to remember any rules, but that's what I've done this a second time for, is because we can use rules. Since the leading coefficient is a 1 on my x squared right there, I know for sure that I'm going to split this up into 2 binomials with x's as the first term in both of the 2 binomials. What I fill in with the rest is whatever I split 20 up from, okay? Again, I'm looking for 2 factors of 20 that add up to 9. I already know, because we already did it, they are 4 and 5. And since they're both positive, we would show these both as plus. So I have plus 4 and plus 5. And the rule allows me to just leave it like that. I can skip a lot of this work. We know from math and a lot of math history that there's no need to doubt that this will always work. You can do the factoring by grouping like this. Either way, you're going to end up with the same answer, just like I did, although the order may change depending on which one you put where, okay? So if you had written this as x plus 5 times x plus 4, not a big deal. But again, either way, you're going to get the same answer, no matter which method you use. This one is always consistent, though, and you don't have to memorize any rules. Other than, again, you'll have to look at maybe factoring out a greatest common factor, which if you do, you have to, but if not, so be it. And that's all we got for this problem.